Hey guys, in this video we're going to be talking about linear versus nonlinear relationships. Alright, so the first problem says that Emily just got a job at Starbucks and they agreed to pay her $12 per hour. Complete the table and graph based on this information. Alright, so she works 1 hour, she's going to get paid $12. So wages is just another name for her salary or what she's getting paid. All right, so 1 hour is 12 hours, so 2 hours would be double that, right? Or 2 times 12 would be 24. If she works 3 hours, that's going to be 3 times 12, which would be 36. And if she works 4 hours, that's going to be 4 times 12, which is 48. All right, so now we need to complete the table. So if we graph these, we're going to go, it's always x first, and then y. So we're going to go over, this is our x, over 1 and then up to 12, which is here. We go over to 2 and up to 24, so over 2 up to 24 would be here. Over to 3 up to 36, over to 4 up to 48. All right, and if we connect these dots, you can see that they are making a what? A line, right? All right, so we want to, if we look at the table again, notice that as the hours increased by 1, every time it went up by 1 hour, the wages always increased by what? It always went up by 12. Okay, so here's what I mean. As this went up by 1, this went up by 12, because 12 plus 12 is 24. As this went up by 1, this went up by 12 again. All right, so when both quantities, x and y, have a constant rate of change, all right? So they were changing by the same number every time. That's what they mean by constant. It didn't change. So it always went up by 12. It didn't go up by 12 and then 15 and then 20. It was always the same thing. If both x and y have the same, a constant rate of change, so they're not the same to each other, but it was the same for x and it was the same for y. When that happens, then they're defined as having a linear relationship. Okay, and you can see the word line in there, right? And sure enough, when we graphed them, it made a line. And so it will not just be a linear relationship, it will graph as a straight line. Okay, and this is always true. So in any table where that change is constant, it will always graph as a line. All right, so what we're going to be doing is looking at tables and determining if they would graph as a line or not. All right, and if they are, we call them linear, and if they don't, we call them nonlinear. All right, so the way to check is to look for that constant rate of change. So I can see from 0 to 5, it went up by 5. From 5 to 10, it goes up by 5. And from 10 to 15, it goes up by 5. Okay, same thing with the y. Now this one's interesting because it's not going up, it's going what? Down. So it's going down 4. So I'm going to use a -4 to show that it's going down. All right, and so what I need to see is that it continues to go down by 4 each time. So if I do 16, if I go to 12, that's also down by 4. And if I go from 12 to 8, that's also down by 4. So since these are all the same and these are all the same, that's a constant rate of change. So we would say, yes, this is linear. And the reason, if we're explaining why, is because it has a constant rate of change. All right, look at the next one. Same procedure. So from 0 to 2 is 2, from 2 to 4 is 2, from 4 to 6 is 2. I'm doing that pretty quickly, but I'm just subtracting these basically in my head. 2 minus 0 is 2, 4 minus 2 is 2. Same thing over here. If I want to know the difference between 0 and 2, how much does it go up? That's 2. If I do 8 minus 2, it's not 2 anymore, it's 6. If I do 16 minus 8, that's 8. All right, so on this side, we have a constant rate of change, but not for y. So both of them have to have a constant rate of change for it to be linear. So in this case, this is not linear. Okay, and you could say the rate of change for y is not constant. All right, look at 3. So again, I'm going to look at x first. 0 goes to 3, so that would be a change of 3. 3 to 6 would be a change of 3. 6 to 9, also 3. All right, this time I'm starting with a negative and going to 9. So I have to go to, get to 0, I have to add 3 and then 9 more. So 3 plus 9 would be 12. All right, to go from 9 to 21, if I can't do that one in my head, you can always just subtract these out to the side. So this would be 11 minus 9 is 2 and 1. So this is also a difference of 12. And then if I want to find the difference between 33 and 21, I also get 12. All right, so these are all 3, these are all 12. That's a constant rate of change. So this is linear because of the rate of change. And again, this is what I was doing for all of these. The numbers were pretty small, so I was just doing it in my head. But if for some reason you didn't know that, you can always write it out. What is 2 minus 0? 2. What is 8 minus 2? 6. What is 16 minus 8? 8. What is 2 minus 0? 2. What is 4 minus 2? 2. What is 6 minus 4? 2. All right, a square has a side length of s inches. Use a graph to determine if the relationship between the side length and the area of the square is a linear relationship. All right, so they're talking about a square. Oops, I'm going to draw a square. Okay, and the length, they're just calling s. So if it's a square, then all the sides are the same. So the length and the width are both side length s, right? And then they want to know the relationship between the length and the area. Well, how do you find the area of a square? You just multiply the two sides together. S times s would be the area. S times s, right? So if the length is 1, then 1 times 1 would be what? 1, right? If the length is 2, so instead of s here, I have a 2. 2 times 2 would be 4. If it's 3, then 3 times 3 would be 9. If it's 4, 4 times 4 would be 16. If it's 5, then 5 times 5 would be 25. All right, so we want to use a graph to determine if it's linear. So now we're going to graph our points. All right, so this table is going a different direction, but you still have x first and then y. So I'm going to start with x. I go over to 1 and up to 1. Well, if this is 4, then 1 is pretty close to the bottom. 2, 4, so I'm going to go over to 2 and up to 4. 3, 9, I'm going to go over to 3 and then a little more than 8. 4, 16, I'm going to go over to 4 up to 16. And for 5, I'm going to go over to 5 and up to 25, which is a little more than 24. All right, so what do you think? Is this forming a straight line? Well, if we connect the dots, then you can see it's forming more of a curve than a straight line. So this is not linear. Or we could say it's non-linear, not linear. And then if you wanted to, if you just want to compare the rate of change just to know for sure, these are all going up by 1, so that's okay, right? These are going up by 1. But from here to here was what? That was 3, and this was 5. So we can stop right there. If these aren't the same, then that's not correct. That's not linear. All right, number 5, Sarah ordered shirts for the track team. Each shirt costs $4 plus a $15 shipping charge. Use a graph to determine if the relationship between total costs and the number of shirts is linear. All right. So if I buy one shirt, that's going to cost me $4, but I have to pay for shipping $15. Wow, that's a lot. Then the total cost is going to be $19. If I buy 2 shirts, then I'm going to have to pay 2 times $4, right? 2 times 4 would be 8, but I still have to pay the shipping cost, which is 15. So 8 plus 15, if you need to write it out, you can. 8 plus 15 is 23. All right, if I want to buy 3 shirts, I have to do 3 times what? 4. 3 times 4 is 12. And then I have to add the shipping, 15. 12 plus 15 is 27. Or if you're needing to, add it up, 27. All right, and then 4, if I buy 4 shirts, I'm going to pay 4 times $4 for the shirts. That would be 16 plus the shipping charge of $15. Okay, and then if I add those up, 16 plus 15 is 31. All right, so now if I go ahead and graph these points, I'm going to go from 1, I'm going to go up to 19, so that's a little less than 20. 2 to 23 is a little less than 24. 3 to 27 is a little less than 28. 4 and 31. Okay, so if this is 28, these are going up by 4, so this line would be 32. So 32 would be, or 31 would be right underneath it. All right, so is this forming a line? Straight line. Yep, it is. So we would say this is linear. And if you weren't sure, maybe you didn't graph your points exactly right, you can always check it by looking at the rate. So these are all going up by 1. Okay, how much did these go up by? Well, from 19 to 23, if you're not sure, subtract it. 23 minus 19, you get 4. Okay, if I do 27 minus 23, oops, and I also get 4. So the difference here was always 4. So that's a constant rate of change, which makes it linear. All right, so that's linear versus nonlinear, and you're looking for a constant rate of change. All right, see you later.